All right, so let's continue with area. Today we'll actually find the area of polygons. So the formula is 1/2 AP. And the A is the apothem. Oh, that was kind of sloppy. And the P is the perimeter. So, this formula works with any shape, really. It doesn't have to be like a pentagon or a hexagon or whatever, but it can be. So, you just need really those two pieces of information. You need the apothem. Let's say it was 6, and then let's say that the length of one side was 8. So remember, they're all regular, which means the sides and the angles are the same. So if you have those two pieces of information, you're good. So the apothem is 6. The perimeter is 8 times 5. So again, you get to do half once. You could do half of 6, then times 40, half of 40, then times 6, 40 times 6, and then do half. I don't care which way. I tend to do half of the larger number, like I said yesterday. And we get 120 meters squared, feet squared, yards squared, whatever length they give. If they don't give a length, they typically would type square units or units squared, just like they would write it out in words. Okay, so that's the easy problem. If I have the side and I have the apothem, then I'm good. So what happens if I don't have one or both of those pieces of information? Okay, so let's look at a problem or two where that is the case. Okay, so you're going to have a couple different kinds, and we're going to back into chapter 9, I think it is, to work on some of these. So, all right. So let's say we had a hexagon, and it gave me that length was 8, and we had I'll use 8 and 6 again. Length of a side is 8. So what I am, in terms of my formula, half, apothem, and perimeter, well, I have half. I don't have the apothem, and the perimeter is 6 times 6, or 36. So I need the red, I guess I don't need to do it dotted, but I need the red length, which would be the apothem. All right, so here it comes. So I need to know the central angle. So that'll be 360 divided by 6, which would be 60 degrees. And then on that triangle on the left, the top angle, remember the central angle would incorporate like all the way to the blue line, the black one and the blue one. But the triangle on the left where the red is, excuse me, well, I guess I could do two things on this one. It would be 30 degrees. Okay, so let's see, because we're going to do like half of it. Okay, so it's a 30, 60, 90 triangle. It's a special right triangle. Okay, And I kind of messed up by just making up numbers like here on this one because the 8 doesn't jive with like the 6. So we're going to end up changing the 8, excuse me, or the 6 rather, to an 8. And I'll explain why in just a second. Because a 30, 60, 90 triangle, we have relationships, remember? So the hypotenuse and the short leg down here, I'm going to show you 2 ways to solve this. One is, if you remember a special right triangle, this short side is a 4. Okay, remember short side to hypotenuse is times 2, which makes the red line 4 square root of 3. And so I could put that in here as 4 square root of 3. And I'm going to multiply it out because it'll help with like the other way to do the problem. So 4 times square root of 3 is 6.9. And I changed the perimeter because I had to use 8 to make it 48. Okay, so that's one option if you special right triangle. So really it's this triangle right here that we're concerned about. I kind of pulled it out to make it a little bit bigger. And I initially figured out that we had 30 degrees here. And we were really after that value for the apothem. So let's say you didn't remember anything about special right triangles. We can still use sine, cosine, and tangent, which we'll have to use if it's not a 30, 60, 90 triangle. So I'm going to do another example in a minute where we're going to have to do that. But so I need to figure out the x, and I have the 30. And I suppose if you wanted to, you could say, well, that's 60 degrees and use 60, but it's kind of not necessary. But so 30 degrees, I have adjacent and I have hypotenuse. So that's cosine of 30 degrees equals adjacent over hypotenuse. So when I do my problem, I just have to multiply those two things. So cosine of 30 times 8, and I get 6.9. So if you do special right triangles, you're going to get 6.9. If you do sine, cosine, or tangent, you're going to get the same answer. So coming back up to the red part up here, I'm going to do half of 48 is 24, and then I am going to actually use a calculator just to speed it up, 6.9, and I get 165.6. Okay, for the area of that hexagon. So hexagons are going to have 30, 60, 90 triangles, no matter what. Okay, so you can use special right triangles, or you can use sine, cosine, and tangent. Okay, but what if it's not a hexagon? First, like problem here, there is another way to actually figure out the apothem. All right, these are a little bit harder to draw, so let me figure out a way to do this. I'm going to try to draw an octagon. I always kind of draw them where I put the 4 sides in there, and then I try to connect them, even though it's going to look kind of oblong. But 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what if we had, here's our, we have a center, and what if this was 6? And that's all it said. Okay. Well, on all these problems, what I need is, so again, if my formula I don't know the apothem. And 6 times 8, 6 for this side, 8 all the way around, 48. So a lot of them, you have to figure out the apothem. Like that's the missing like piece of information. So again, I need to start with the central angle because I need to create a triangle in the like middle there. So in this case, I'm going to do 360 divided by 8 is 45. So I've got this triangle. I'm going to pull it out of the picture to draw it a little bit bigger. And here's one like nice thing is this side is 6. It's always like kind of bisected at the bottom. Okay, and then it's also, so this 45 for the central angle, that's the red like part, but I only want half of it. So half of 45 is 22.5 degrees. And I'm trying to figure out that. So in this problem, like there's no special right triangle or anything. I have to use sine, cosine, tangent. So I have 22.5. So what sides do I have? I have opposite and adjacent. So that's tangent of 22.5 equals the opposite is 3 over x. So when I multiply the diagonals, I'm going to get 3 equals tangent 22.5x. And then I'm going to divide by tangent of 22.5 on both sides. And I'll get x equals like whatever that is. So let's do that. 3 divided by tangent 22.5. And I get 7.24. And I don't... I'm trying to see like what does the book usually round off to. It appears to be a tenth, so we'll go 7.2. Okay, and so that is the apothem, which means up here I'm going to do 7.2. Okay, so again, oops, I'm going to do half once, and I like to always do half of the bigger numbers, so half of 48 is 24. And so we'll have 7.2 times 24. And we get 172.8. Okay, so when you have to find the apothem, almost always you're going to have to do some form of like sine, cosine, or tangent. Now, there is another like way, depending on the information given to you. So we can kind of go back to that. So let me kind of show you that option as well. So yeah, I'll go back to a pentagon. And so if it gives you the length of a side, and it gives you the radius, or this length from the center to a vertices. And so again, I'm still looking at like what's this length right here. Okay, but if you remember, like on the last one, I pointed it out. If this length is 5, it cuts it in half down here. So they're each like 2.5. 2.5, 2.5 equals 5. So what I have, again, let's pull this triangle out. Well, I know 2 sides, and I need to figure out the third side of a right triangle. So I can do x squared plus 2.5 squared equals 6 squared. And I can just do Pythagorean theorem. I don't know why I put equal right there. 6.25. So I'm going to subtract 6.25, and I'm going to get 29.75. Just remember to do your subtraction right. And then I'm going to do square root. So square root of 29.75 is 5.5. It's 5.45, but we're going to round it up. Okay, so again, on this one, half apothem perimeter. So the apothem I figured out down here was 5.5. The perimeter is 5, like this side is 5. 5 times 5 is 25. And so now we're like, uh-oh, we don't have any like half. What can I do half of? Well, I mean, you can do half of an odd number. We're going to get decimals here anyway. So, and I'm going to use a calculator anyway, so I might as well just do 5.5 times 25, and I get 137.5, and then I'm going to just divide that by 2 for half and get 68.75. So sometimes if you get both odd numbers, you can do half. I mean, half of 25 is 12.5. So if you did 5.5 and 12.5, you're still going to get 68.75. So it really doesn't matter, like I said, which way you choose to go at it. Okay, so you're going to have some problems where you're just going to find the area. And then you're going to have some where it's going to say, a couple of those, like, what did they do wrong? And then you're going to have some where it's just find the area of the shaded region. So I'm not going to do any specific problems per se, but just to talk in general. So if I'm finding the area of the shaded region, I'm going to do the area of the circle minus the area of the triangle. Okay, or like whatever, like most of the problems are like that, where it's a circle, you have some shape inscribed inside the circle, and then you're going to find the shaded area, which is on the outside of like that shape. So whatever it is, like one of them is the area of a rhombus, or it's a rhombus. It could be a square, but I don't know. It's a rhombus on the inside. So remember, rhombus, it's half diagonal 1 times diagonal 2. One of them is a pentagon. One of them is a triangle. And then the other one's a triangle also. So you're still going to do do the half apothem times perimeter for each of the polygons. So that's what you'll use for your area of like the triangle or whatever polygon you have. And then just remember the area of the circle is pi r squared. So you'll need to, and remember the radius is going to be like from the center of, like, for instance, the triangle here on this one. Whatever the center is, the radius is going to go to the corner, like to a vertices in any of the shapes. It'll go from the center to one of the corners of the triangle or the pentagon or the hexagon or whatever shape it is. Okay, and so I'll tell you that on 2 of them you know the radius from the get-go, and then on a couple of them you don't, and so you'll have to figure that out as part of the problem. Okay. All right, so this isn't like necessarily the easiest like one, but we'll give it a shot and see where we go. All right, have a great day, guys. Good weekend. We'll see you Monday.